Unit 10, Review, Part 4. So these are the last two problems that are on the front side of the review. So number 9 and number 10 both are graphing conic sections. So taking a look at number 9, the two things that we really need to notice about number 9 are that there is a plus sign in between and that it's set equal to 1. Okay, so we have a plus sign in between, it's set equal to 1, and then we have these denominators over here under each one. Okay, what this indicates is that it's the basically it's a translated ellipse. Okay, it's a translated ellipse. So we know that it's an ellipse. Okay, and the reason that we know that is because the standard form of an ellipse, or one of the two standard forms of an ellipse, is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now, the thing about an ellipse is that a is always the bigger of the two numbers. So we know that this is specifically an ellipse that's been stretched in the horizontal direction. It has a horizontal major axis. Okay, so we know it has a horizontal major axis because the bigger number is underneath the x term. Okay, that means that it's been stretched in the x direction. Okay, we can find the center just like we've been finding the center of our other two translated conic sections, hyperbolas and circles, using h comma k. In parabolas, h comma k represents the vertex. In the other three, h comma k represents the center. So based on the information that we're given, okay, if we're given that it's x plus 4, that means x minus h means that h is negative 4. Okay, it has to be the opposite of whatever that sign is on the inside. And then y minus k means that if we have y minus 5, then k is 5. Okay, so our h comma k, our center, is negative 4 comma 5. And we have a scaled axis here, so I'm going to go to the left 4, and then I'm going to go up 5, so that puts my center right about there. Okay, and it's not quite exact, but it's close enough. All right, so our center is at negative 4 comma 5. Our major axis is the horizontal direction. So in the x direction, we're going to go a units to the left and a units to the right. Well, since a squared is equal to 9, that means that a is equal to 3. So I'm going to go 3 units to the left. So taking into account the fact that my units are 2 units per lattice point, I need to go 3 units to the left and then 3 units to the right, and that takes me kind of right in the middle of those squares. Okay, and then my b represents the distance from the center to each of my co-vertices. So since b squared is equal to 4, b is equal to 2, and I go 2 units up and 2 units down. And this gives me enough information to then draw my ellipse. It's been stretched only slightly in the x direction. So my circle's only been squished a little bit. Okay. Now moving on to number 10. It looks very similar. It's been set equal to 1. Okay. We have denominators. Okay, we have the only difference really is that we have a minus sign in between, and this indicates that we have a hyperbola. Okay, so we have a hyperbola, and because the y term is positive, okay, that means that we are going to have the branches of the hyperbola opening up and down. So because the y term is positive, that means that the hyperbola branches are going to be opening in the y direction. If the x term were positive, then the branches of the hyperbola would be opening in the x direction. So we have our standard form for a hyperbola with the branches opening in the y direction would be y minus k squared over a squared minus x minus h squared over b squared equals 1. So now that we've got it looking like the right equation, we can easily identify our center. Our center is again going to be h comma k, okay, just like it was over there for our ellipse. But we need to remember that now the h is over on the other side. So we have x minus h, so that means that h is equal to 3. Okay, and y minus k, which means that k is equal to negative 2. So we have 3 comma negative 2. Watching out for our units again. It's the scale is by 2's, so 3 comma negative 2 means that my center is going to be right there. My vertices are a units away in the y direction because the y is positive. So my vertices are a units away from the center in the y direction. So a squared is equal to 9, which means that a is equal to 3. So I have a vertex 3 units up and a vertex 3 units down. So those are my two vertices. Now the last thing that I need to do is I need to get the excuse me for a second while I change color here. Okay, the last thing I need to do, or not the last thing I need to do, but the next thing I need to do is get the rectangle, okay, that identifies my asymptotes. And the way that I do that is I go b units to the left and right. So since b squared is equal to 36, that means that b is equal to 6. So I'm going to go 6 units to the right. So 1, 2, 3, 4, 5, 6. 6 units to the right. And I'm just going to make a little tick mark there. And then 6 units to the left. 1, 2, 3, 4, 5, 6. Okay, make a little tick mark there. And that's going to define the width of my rectangle that I'm going to use as my guides for my asymptotes. I already have the height because that's the vertices give us that. Okay, so I'm going to finish out my rectangle here using those dimensions. Okay, so there's my rectangle. Okay. And then from there I'll go ahead and draw my asymptotes as best as I can. Okay, not too bad. Okay, and then going the other direction, draw my diagonals to get my asymptotes, and of course when we get these done, that means that we're ready to draw the branches of our hyperbola. So we'll switch back to blue. Start from each vertex and again approach, but don't touch the asymptotes. Do that from either side, and notice that we have a nice wide hyperbola branches there. Okay, and that's it.